First, I would like to thank you for the opportunity of speaking about cookeroods in the Nordic countries mainly, and it's quite clear when we see the other presentations from America and also from Bosch Siemens that they have different challenges that we have here in the Nordics. My first slide here, it's a print screen actually. It's from the Norwegian technical description of building houses, and we see that the recirculation shall not be used if it contaminates room where humans are present, it says. And it also says that the kitchen, toilet, and bathroom needs extraction with satisfactory efficiency. Listening to the other speakers here, it's clear from our perspective also that the capture rate is the most important thing of a cookerood. And the capture hood and the capture efficiency is based on the design of the cookerood, the flow rate, and also the installation. In Norway, we have a legal demand certified which describes 108 cubic of forced ventilation per hour. This is the extraction through the cookerood, and this is the absolute minimum. We know at this level of extraction that we don't have high efficiency on the cookerood at all. So this is just a minimum figure that we all the time try to get away from, so to say. In Denmark, they have also the same, I would say, description in minimum capacity, although it's a little bit higher. It says here that we need to have at least 20 liters per second in the, let's call it the normal ventilation, and then we have to have at least 144 cubics per meter in the period of cooking. And to be a little bit more in detail on what actually happens in each kitchen here, we have done some tests in terms of the European label according to the normal test facility. And then we have also made the test with the Swedish label, or the Swedish tests that Mr. Sein spoke about a little bit earlier. And we see a quite big difference between these two test methods as described earlier. We see the test without any air disturbance, and we also see the test with air disturbance. And we like to say that the test in the laboratory with the low airflows is not valid for the tests with air disturbance at home for each consumer. We see a quite big gap of the odor reduction factor of how much of the, let's call it the fumes that the cookerood can extract from these two methods. If we have a look at the top level here, we see it already at 30 liters per second, which is the minimum level, 108 cubics. We have a quite high efficiency rate on the cookerood in the laboratory. When we see this with air disturbance, we say there's a huge gap with the low airflows that we experience in the legal descriptions in each country. And then when we add a better efficient or a higher airflow rate, of course, the gaps between those two measurement methods decreases, meaning that there is almost the same measurement level if we go up to, let's say 90 liters per second, which is about 300 cubics an hour. So this again comes down to the design of the cookerood. On very low airflows, we can experience very good efficiency rates in the laboratory, but when we go to the air disturbance method, we see there's a huge drop in efficiency, and this also demands a cookerood with a quite big volume function, like call it a big kitchen, sort of speak. When we here go to the way that the end consumer would like to have the cookeroods nowadays, it's without this big volume function, meaning that they would like to have a slimline version or a T-shaped version or even a vertical version that we spoke about earlier. We see there's a huge drop in efficiency on the low airflows, and we would need to add more air to achieve a better efficiency rate. So in order to maintain the 75% efficiency rate that we recommend for the Nordic countries, we would need to be around 140 cubics if we have a small volume function below the Cuckoo. We would need to be at 165 cubics of a slimline, a pull-out, a built-in unit, and on a vertical Cuckoo, we would need to be at approximately 200 cubics an hour to achieve a 75% efficiency rate on the Cuckoo. When we go to the European label, it's not really helping the Cuckoos in the Nordics because we have a demand for inlet air also. So this is for us in the Nordics more or less a comparison between different Cuckoos, and it doesn't really say anything about how well the Cuckoo works. All of these symbols are performed on the level 3 or the level maximum before intensive speed, and this doesn't really give us a good indication on how the Cuckoo works. When we see the study also from Ian here, when only 40% of the people turn on the Cuckoo, it's clear to us also that it's sort of like a low interest product, but still it's very important for the indoor climate in each house. So I would like to spend a little bit more time now on talking about the let's call it the grease filter efficiency, and also about the level 3 on the fluid dynamic efficiency. The Ian label, from our point of view, is a good tool for comparisons between Cuckoos, as I said. But since we cannot really determine the right installation of each house, it is quite impossible actually to calculate what kind of efficiency will be for each consumer. On a normal Cuckoo, we would like to consider that we may have even 6 meters of ductings. We may have 290 degrees angle, and we might also have an outdoor wall grill, which will give a quite different performance, we can see here on the purple line, than we have on a normal EN regulated Cuckoo, where we see here with a standard mode. And if we then have a higher pressure drop over the system, of course there will be less cubics, which will be, let's call it, taken out of the apartment, and we would also need then less cubics in the apartment since we have very airtight houses here in the Nordics. Regarding the grease filter efficiency also, which we have a very good presentation of from Martin, I would like to also add here that since it is only based on level 3, in the EN regulation, it really, or the EN label at least, it doesn't really gives us a good performance that we can trust. When it comes to charcoal filters, I would like to give some explanation about this, the way that we see it in terms of the Metyl Etyl Kotan standard, but we have also made some tests here where we call it a real life cooking here, where we have made some hamburger boiling here, which I will present a little bit later. When it comes to plasma filters, I also support the conclusion of Martin here that since we don't have a standard measurement, it's quite difficult for us to conclude if it's a good filter or if it's not a good filter. So we'll leave that open. When it comes to the carbon filters, it's also on the Cuckoo max normal level, and that same is for the monoblock filters that we are using in our Cuckoos. What we see is that when we are using filters, it gives a quite good effect on the MEC concentration in the room. So, sorry, if we try to follow the green line here first, we see the increasement of the MEC concentration in the room without using any filters at all. And then we see also that it's a quite high stable level inside the room. So this clearly states from our point of view that using charcoal filters gives an effect on the MEC. And then when we see there are different types of carbon filters also on the market, we see that the quality of different suppliers will make it almost impossible for us to determine what kind of level we would like to be on in the market for the end consumer. We also see that this is performed during a test when the carbon filters are brand new, the cooker is brand new. And we are quite concerned about what will happen with the charcoal filters when we see that the end consumers doesn't even care about their grease filters. They don't wash them, they don't maintain them. And what will then happen with the charcoal filters after some period of time? We know that the end consumer, they will not change them. We know that they don't really care about the cooker this much. So maybe the best option for the end consumers may be that the cooker starts every time that the stove or the gas hobs starts up. Can be an option to help this situation. It's very important for us that we can document the extraction rate and also the odor reduction on each cooker that we present. So according to the standard, it needs to be done on setting 3, which we have spoken about. And we need to add the Metyl Etyl Kotan, the MEC, for some period of time, and then we will get 3 different tests and a filter average of that, which will describe the level of odor reduction. Our concern is that we know that the end consumer, they don't use the cooker on level 3. And as Martin also showed earlier, we need to be on level 3 or level 4 to have a good efficiency on the cookers. So it's quite difficult to state if we can conclude with, is charcoal filter a good solution or is it not, when it's only measured on level 3 and only measured with MEK. So we done some further tests on this and also added some fish odors to see if there is a difference between the MEC and the fish odors. And this is in recirculation mode, also on level 3 with the trimethylamine. And we see that with the odor reduction level also on level 3 is quite good. So it is possible to get a very good, let's call it the odor reduction level on the MEC and also on the fish odors according to the standards. But what does this actually mean for the end consumer? And this is part of our challenge now. So we think that the Metyl Etyl Kotan does not represent a real-life cooking situation. So we have now performed some tests where we have boiled hamburgers, 3 hamburgers at the exact same temperature with the exact same amount of oil and butter. So the tests are performed 3 times at the equal facility. We have made 12 minutes of cooking sequence. We have enough inlet air so that we can see that the duct out is working. And we have made identical plates, as I said. Now we are measuring TVOX. We are measuring amino sulfides, aldehydes, ketones, and organic acids. And here it's quite clear to us that we can see that the red line here is no ducting at all. And then we see the orange line, which describes the best charcoal filter that we have with a 97% odor reduction level according to the MEC standard. And then we see the duct out, which is the blue dotted line. And we see here that two things. It is very important with the after ventilation, which we can see here, which decreases the volatile organic compound quite drastically. And we can also see that there is a 35% difference of the quality of taking away the volatile organic compounds in the period of cooking when you compare duct out in terms of recirculation mode. We also did the same test on the plasma filters. According to the monoblock filters, we cannot see that the plasma filters are better. We can see that there are good filters, but cannot prove that they are better at the moment. And now that I see that my time is up, I would like to finish with this slide. that with the information we have at the present time, duct out is, in our point of view, 35% better than recirculation was in the performed tests. So thank you for listening.